Hi, I'm Alex Alvarez and welcome to Dynamics 7. In this tip we're going to be talking about the instancer, which is a technique that you can use to replace each particle in a particle object with a piece of geometry. And the geometry can be either static or it can be animated. So if you had static geometry, you could have, for example, a library of rocks or boulders that you could then, or meteors, and you could then use those, use that library and replace each particle to create like an asteroid belt or a rock slide, a meteor shower. Or if you had an animated piece of geometry, like a butterfly flapping its wings, or even a robot walking or a buffalo running, any of those could be placed on the particles. So if you had, let's say, used goals to get particles to flow along a surface, you could then use the instancer to replace each particle with a walking character. It's a very wide range of applications that the instancer can be used for, and we'll be talking about all the attributes you can use to create a lot of variety in how each piece of geometry is placed on each particle. And so there you go. So to begin talking about the instancer, what we're going to do is we're going to start with a simple example and then get progressively more complicated as far as what we're doing with the geometry that's going to be placed onto the particles. Right now what I have is some tanks that are just driving forward, and what we'll see when I play this little movie is they speed up, drive for a little bit, and then slow down. And what we are using here is the instancer, and so I started with a single tank and then placed use the instancer to get that single tank to be instanced onto a bunch of particles, and then those particles are being pushed in the x direction using a uniform field. And so for an example like this, we're not worrying or concerning ourselves with any scaling or rotational issues, in the sense that each tank is just pointing straight forward, they're not turning, and they're all the exact same size. So let's start by taking a look at how something like this is put together. And so I'm going to actually get rid of the particle object, the field. I'm going to get rid of everything in here, and I'm going to bring back my original piece of geometry, so that what I'm looking at is this. And if I select it, we'll see that if I select the root, that we do have a tank, which is a single object from the point of view of it all being grouped together. But if I go in, you'll notice that I can start selecting components if I just use the selection mask in object mode for poly object. So if we look in the hypergraph, we'll be able to see that this tank is actually made out of multiple surfaces. So something as far as that you're allowed to do with the instancer is you can instance any piece of geometry, either poly or NURBS, onto particles, and you can either select individual surfaces or you can select a hierarchy. So if I select a transform node that is the parent of multiple objects, like in this case with the tank, you can't instance that. And so that's going to be useful for a very wide range of things, obviously. And so what I'm going to note or point out next about this object is the fact that when you're going to instance a piece of geometry onto particles, there are a couple things about the geometry you're going to want to check, aside from it being grouped together. Notice that the object is at the origin right now. I could have the object, if I wanted, moved anywhere in the scene, but when I create the instancer, that doesn't matter so much. But what does matter is that when the object is at the origin, you want to make sure that if you look in the channel box, everything says 0, 0, 0 for translate and rotate. The scales don't matter as much. Right now it says 1, 1, 1 for scale, but you do want to concern yourself with the translate and rotate. And so that if I took the object and moved it over, very far away, I want to know that if I enter values of 0 for translate, that it's going to go back to the origin. So that's the first thing you're going to need to make sure you do. So if your object, when it's at the origin, does not have everything at 0, 0, 0, you would simply select it and then go to Modify, Freeze Transformations, so that everything gets zeroed out. The next thing that you want to check is the rotations. Specifically, you want to make sure that the nose of the object, or the front of the object, is pointing down the positive x-axis. And so for this tank, if I look at the gun, and then I look at my local rotation axes, or my origin axis, I can see that the x-axis is pointing this way, to the right. And so my gun is pointing to the right. And that's a very important thing to make sure you do when you're going to be controlling or using rotational aspects of the objects. And this will become clearer a little bit later. And so right now it's pointing down the positive x-axis, and everything is 0, 0, 0 for its rotations in x, y, and z. And then the third thing you're going to want to check is where the pivot point is located for the geometry. For this tank, what I can see is that the pivot point is actually underneath the tank. And so the pivot point is right down there. Basically, the pivot is on the ground. And that is important because when you replace particles with geometry using the instancer, the geometry is placed onto the particles based on where the pivot point is. And so in the case of this tank, if I have particles that are flowing along this surface using goals, or if I have particles that are resting on the surface using collisions and gravity, I would want to make sure that the tank's treads are not intersecting or going through the floor. And so you'll check that by just looking at where the pivot point is. So again, you want to check that your translates are at 0, 0, 0, your rotates are at 0, 0, 0, that the front of the object's pointing down the x-axis, and that the pivot point is wherever you need it to be based on what you're trying to do. And so for the case of this tank, I want the pivot point to be on the ground. So with all of those things checked, we are now ready to use the instancer. So let's first create some particles. The particles can be created in any way, in the sense that you could use emitters, you could have particles emitting off of a surface or off of a curve, or we can create particles with the particle tool, which is what I'm going to do right now. So going to the particle tool, I'm just going to place individual particles down by just clicking with the left mouse button. And so basically everywhere that I place a particle, I'm going to get a tank. And so since I know that's what I'm doing, I'm going to make sure that I do not place a particle so that it's too close to another one, because I don't want to get tanks intersecting each other. And so now if I hit enter, it's very hard to see the particles. So for these particles that I've just created, I'm going to turn them into sphere mode so that they are easier to see. And so let's say we'll go in here and also make them red, because that'll also make them a little easier to see. And now that I've done that, what we can see is I've got all these particles. And so I did go and place a particle very close to my original tank. That doesn't matter, because when you instance this piece of geometry under the particles, your original piece of geometry, which is this tank right here, is not actually going to be used, and I could just go ahead and hide it. So now that I've got the particles placed in the scene, what I'm going to do is select the geometry. You do not need to select the particles. So I'm just selecting the tank, and I'm going to go to the particle pull-down menu. And in here you'll see that we have something that says instancer, and then in parentheses it says replacement. And so this is what we're going to be using. If I go to the creation dialog box and hit edit reset, notice that there are actually quite a few things we're going to need to talk about. And they're kind of categorized in here. But what I'm going to do is let me just hop in, get a sort of screen grab of this open so that you can kind of see what we're going to be using. And so if I just get the window open, what I'm looking at here is the creation dialog box for the instancer. And for the instancer, you'll see that at the top it asks you, for a name. You don't have to specify anything there. If you don't, it'll give it a default name. Then it asks you how rotation is going to be handled, level of detail, cycling, which has to do with animation. We're not going to look at any of that just yet, because we're going to get to rotation later. But I just want you to, have a look at the types of things we're going to see in here. But then you will see underneath that it says instanced objects. That is going to list any objects that you have selected when you open the instancer. You do not have to have just one object selected. I could have 10 objects selected. I could have a library. So that instead of having just one tank, I could have 10 tanks that all have maybe different shaders on them or whatever. If we cruise down a little bit, you'll see that it's asking which particle object we're instancing. Then it's going to ask us how we want to handle position, scale, visibility, how we want to handle rotations, and cycling. So there are several options, but for now, we're not going to talk about any of these. I'm just going to go back to Maya and have everything at the defaults. I'm not going to touch anything. And what I will see is that where it says instanced objects, it does say tank. So that's the list of objects that I have selected. So down at the bottom, I'm going to hit create. And what we immediately see is that I have a bunch of tanks. And my original tank is still there at the origin. And if I open up the outliner, what we will see in here is that I now have my original tank, I have my particle object, and then I have a node called instancer1. And so if I select that node and delete it, I'm deleting the instancer that I've created for the scene. So if you ever want to undo creating the instancer or just get rid of it, you just select that node in the outliner and delete it. If I get it back, what we will notice is that we were only getting tanks at the location of where those particles were. My original tank is not highlighting when I select the instancer node. So I'm going to select my original tank, the one which is at the origin, and I'm going to hide it. So display, hide, selection. And so here we go. Now I've got a bunch of tanks, and notice that they are all resting on the ground correctly. So the treads are not going through the ground. So notice that those particles are still there. We do not replace the particle with the geometry, it's just we get a copy of the geometry at the location of the particle. Another thing that's important to point out is, let me get my original tank back for a second, is the fact that it is called the instancer for a reason, in the sense that when you select a piece of geometry and you go to Edit, Duplicate, in the Creation dialog box, it asks you what type of geometry you want to create. And here it says Geometry Type, Copy or Instance. When you make a copy, what you end up with is a duplicate, which is independent object, meaning that it has its own shape node. It can have its own shaders, you can do deformations to it, whatever. It's independent of the original. But if you create an instance copy, what that means is that your duplicates share the same shape node as the original. So that if I look at here, what I will find is if I select my original tank, and let's say turn on some of the vertices for it, and for those vertices that I'm going to display, let's say I select some. Notice that when I select vertices on my original tank, the corresponding vertices highlight on all of the other tanks. So hopefully this is making it very clear in the fact that the instancer creates instance copies. So each one of these tanks has to share the same UV coordinates. They all have to use the same shader. And so there's nice flexibility in the sense that if I need to change anything about how the, let's say, texture lays out over these tanks, I just have to change the original and it'll update on all the other ones. But if we wanted to have a situation where I did have 10 different tanks, so that each particle randomly selected from a library of tanks, you would have to actually have 10 source objects before you go to the instancer. So with that pointed out, another thing to say is the fact that when you use instance copying, there are certain things in Maya that you cannot instance copy. And one of those things is a light. And so you cannot use the instancer to replace each particle with a light. And there is a way to do that, which I will show you, but it doesn't actually use the instancer. It uses a script. Because sometimes it's a very necessary effect if you're doing something like pixie dust or fireflies, where you want each one of those fireflies to actually be illuminating the scene, you'd need to get a point light to be located at the position of each particle. You cannot use the instancer to do that, but I'll show you how you can. So let's hide the original tank again. So let's go and get rid of that. And now that I've got these tanks on particles, what I can simply do is if I select the particles, so I've now highlighted those particles that are in there, we can see that they are selected. I can now apply a field to them. If I go into, let's say, fields and create a uniform field, I'm going to create a uniform field that's going to push them in the positive X direction. So I'm going to turn off the attenuation on my uniform field and start playing with the magnitude. And also the directionality of my uniform field is in the positive X axis. So these tanks are going to move to the right. Well, one thing that you also need to be aware of with particles, as far as when you control them with fields, is particles have an attribute called conserve, which stands for conserve momentum. If you are trying to use particles to control things like tanks or fish or butterflies or all the different things you can do with the instancer, the conserve attribute very often will need to be turned off, because conserving momentum, while being natural for certain types of things, for something like a tank, wouldn't necessarily be the behavior that I want. Because if I want to control how these tanks drive around the ground or move forward or turn or whatever, I'm probably going to want to do that completely by using fields. And if that's the case, it's very useful to know that if I turn off my fields, that my objects will stop. Well, if you use conserve and have that at the default value of 1, your particles will not stop when the field turns off. So I'm going to put the conserve to 0. So that if I now go in here and I hit play, we'll see the particles are not going to move. But I already have some animation on my camera. But the tanks themselves are not actually driving forward. If I now select the uniform field, which has a magnitude right now of 5, the magnitude is very, very small. We're not really seeing an effect on the particles. But if I put the magnitude, let's say, to 500, and now I hit play, Now we can see those tanks are definitely driving forward, and they're actually moving faster than the camera is, although the camera is starting to catch up. And so there you go. So now we have a bunch of tanks that are driving forward simply by using the instancer, a piece of geometry, and a uniform field. If I want the tanks to, let's say, start off at rest and then speed up, all I would need to do is go in here, grab my uniform field, set some flat keyframes. So I'll put the magnitude to 0, set a key on the uniform field, and then let's say maybe at frame 20, I'll key it again. And then at frame 60, or let's say frame 70, I'll put the magnitude to 500. So what that means is that the tanks are going to start speeding up at frame 20. Then they'll cruise along with that speed, let's say until frame 150, so I'll key the magnitude. And then at frame 180, I'll put the magnitude to 0, which means that they are going to be stopped again at frame 180. And if I now go in here and let's say, play blast this in, we'll see the tanks are moving very, very slowly in the beginning. But if we look at the tank treads in relation to the grid of the ground plane, we'll see that they're starting to speed up, and they're starting to move, and they're now crossing those grid lines. And so once we hit frame 60, they're at their top speed. And they're going to maintain that speed until they hit frame 150. And then if the conserve was still at 1, they would not slow down once we hit frame 150. But since I know that the conserve is a value of 0, once I hit frame 150, those tanks are going to slow down and stop. And then at this point, what we can see is those tanks are no longer moving anymore. The camera still is, but the tanks have actually come to rest. And so once this play blast comes in, we can see those tanks are driving, and then all of a sudden, they slow down, and now they're not moving anymore. So it's a little hard to see that in relation to the camera, but if you look at the position of the tank tread relative to the grid line, we can see that those tanks are no longer driving forward towards the end of this animation. And so let's actually go in here, and let's choose a new camera. And so for this new camera, if we look from a further distance, it'll also be obvious that those tanks in the beginning are not moving, but once we hit frame 20, notice that they start to speed up. And once we hit frame 60, they're at their top speed. And if we move to the right a little bit, once we hit frame 150, we'll see that they slow down. So that is our first example of the instancer. A very straightforward example where we don't deal with rotation, we don't deal with scale, we just deal with getting particles to have geometry on them, and we also are just dealing with how to get those particles to be easily controlled using fields by setting the conserve to 0. Another example where you wouldn't concern yourself with rotation is going to be doing something like pixie dust, although you might concern yourself with scaling issues. So I'm going to make a new scene, and let's create some pixie dust. Now there are several ways in Maya to create something like pixie dust. You can use software rendered particles with a shader glow effect on them. You could use sprites. But another way to do it is to use the instancer, where you replace each particle with a paint effects stroke. Maya does allow you to instance paint effects brushes onto particles. And so the first thing we're going to need in this scene is to create some sort of paint effects stroke to instance. So the first thing I'm going to do is just put a directional light in the scene. And now that we've got a light, I'm going to go to the paint effects window. And now that the paint effects window is open, I'm going to open visor so we can select a brush. Now there obviously are many different brushes in paint effects, and as far as default brushes. Any of these can be used and replaced onto a particle object. And so, for example, if you went in and grabbed some of the nebula type ones or the space gas ones, you can get some interesting effects to very quickly fill a large area with something like that. But for now, what we're going to do is focus on a glow so that we can use or do something like pixie dust. And there's a glow called laser glow, one of the preset brushes. I'm going to select that brush. And with that brush selected, in the paint effects window, what I'm also going to want to do is open up the brush settings and increase the global scale so that the brush is going to be created a little larger. And I'm going to create the stroke at the origin. Just like with the tank, how I wanted that tank to be located at the origin so that it's translate XYZ 000 brought it to the world space 000. When you're going to instance paint effect strokes, it's the same issue. So I'm just going to create this stroke at the origin. And so now we can see that I've got this little glow effect. And if I tumble around, the thing that you'll notice, and let me go in here and say that I want these to be rendered. We've got our stroke, and if I look at it from the top view, it looks nice. But if I look at it from the side, what we will see is that it's going to look flat. And so that might be useful for certain types of effects, but for what we want to do, we actually want it to be have a little bit more a sense of depth and dimension to it. So we want to do something more like an urchin, where it's completely round. And so to do this, I'm back in my perspective window, and you'll notice that this brush you won't be able to see because its default color is black. So the first thing I'm going to do is select that paint effect stroke, go to the attribute editor, and if I go to the tab that has to do with the paint effects brush settings for that stroke, what I will see in here is that I can go to where it says shading, and we'll see that we have shading and tube shading. If I raise those colors to white, we will now be able to see our paint effects brush. Now when you render, you don't want to do that. When you render, you'd set those back to black so that it just renders the incandescence. And let's switch to rendering at, let's say, 640 by 480. And let's re-render that. So this is what it looks like rendered. But now let's get it so the object is no longer flat like it is right now. To do that, I'll go back to the brush settings. So I'll go to the attribute editor. And you're going to want to go to the tubes folder. And within tubes, there's a folder called creation. And inside here, you will notice that where it says tube direction, underneath that, we have elevation minimum and elevation maximum. I'm going to set my elevate, right now they both say 0. I'm going to put them both to a value, let's say elevation min of -1. Now we get this. And then our elevation maximum, I will set that to 1. And now you can see we get something that for something like pixie dust might be a little bit more useful because we can tumble around it, have it still have, you know, an orientation that's the way that we want. So now if I go in here, go back to my shading, and set the color back to the default black. So let me put both those to black and render. We now have more of a 3D result. And I'm going to put a little bit of glow on that. And so I'm now going to go to the glow folder. And let's add a little bit of glow and a little bit of shader glow so that we can see what this is going to look like. And wait a couple seconds. All right, so now you can see that we have this paint effect stroke, which has a pretty cool, glow effect on it. So now we want to instance that onto particles. And so we need to create an emitter. And so first let's grab that paint effect stroke, make it easier to see. So I'll change the shading and make that white. And now let's create an emitter. So we're going to use simply a Omni emitter. So I'm going to go to Particles, Create Emitter. I'm going to go to Omni, Create. Now I get this emitter up here. And maybe we'll put that on a motion path. And so I'm going to create a CV curve. I'll just place a few points down on it. And then I will grab the emitter and select the curve and go to animation mode, animate, attach to path, and we'll put it on that curve for maybe 4 seconds. So 120 frames. So let's make it 9 seconds so it's cruising a little faster. So I'll hit attach. And then now when I go in here, I also want to take that emitter, and we're going to have to figure out the correct rate. If I hit play, what we will see is we're getting a lot of particles. And let's get those particles to be easier to see. So I'm going to put them into sphere mode, make them a little bit smaller, and we'll make them red again. So that now we can see when I hit play how many particles we're getting. So that's a little bit more than we need. So I'm going to select the emitter. I'm going to increase its speed and lower its rate down to, let's say, 5. So that now when I hit play, we're not getting too many of them. And what I now want to do is also go in and take the rate of that emitter and keyframe it so that when it gets to the end of that curve at frame 90, the rate goes to 0. So I'll set a key. And now if I hit play, we're going to see it's just going to emit particles, and then at frame 90 it stops. So at this point, we're ready to use the instancer. What we're going to need to do is select that paint effect stroke, and then go in Dynamics mode to Particles, Instancer. And in the Creation dialog box, everything still will be at the default. It automatically will, where it says Particle Object to Instance, it will list any particle objects in your scene. So right now, since we only have one particle object, it just says Particle Shape 1. If we had more than one, you could choose which particle object you want to use. So again, you do not need to select your particle object. And then where it says instance objects, it says stroke laser glow. Another thing to point out is if you look in the outliner with paint effects, you will see that there are two curves. There is your stroke and then your regular NURBS curve. You want to select the stroke, the one that has the icon that represents a paint effect stroke. So with that selected, we're going to go to the instancer. Everything's at the defaults, and I'll hit create. And now if I hit play, what we will see is that I now have these paint effect strokes placed onto each one of these particles. And so once we sort of let this go a few seconds, you'll notice that when you end up with a bunch of paint effect strokes, things can get a little bit slow. But before we deal with that issue, let's just sort of do a quick render so that we can see that we now have this paint effect stroke instance on the particles and everything's rendering correctly. And since we had just one paint effect stroke, they're all going to be red. If you wanted some to be red and some to be blue and some to be green and have multiple colors, you would need to have multiple paint effect strokes in there so that you can choose from that library. But either way, you can now see the result that we got by using the instancer. So it's very straightforward. So as far as the performance, so that let's say it plays back faster, if you open the outliner and select the instancer node, and the node is called Instancer 1. If you go to the attribute editor for that, you will see that there's something which says level of detail towards the top. And there's a pop-up menu that says geometry, bounding boxes, or bounding box. If you just choose bounding box, what you're going to see is your playback will get very quick, but it's hard to see where the particles are because you just get a bounding box for the entire thing. So that's why you may want to choose bounding boxes. And now what we will see is we'll get a bounding box for each individual stroke inside there. So the playback is now able to be close to real time, and you get a pretty good idea of where you are, but now we can tumble very quickly. So this is very, very handy, especially if you wanted to create a forest, for example, using paint effects brushes instanced onto particles. That can definitely get very slow from a tumbling and interaction point of view. So you just use bounding boxes. So putting it back to geometry, we're going to see this result where they're all this color. So now let's say we get into some other things. Right now they are all the same size. None of them are rotated or oriented differently. So let's say we wanted some to be different sizes than others. To deal with size issues, what we need to do is we need to select the particle object, because if you look in the creation dialog box for the instancer, you will see, and let's say starting at the top and then looking down, where it says general options, the only thing in here that's going to have that's not going to say none is position. Notice that you have all these attributes that can be mapped, but by default they all have a setting of none. Position says world position. Well, what that basically is saying is that the position of each piece of geometry will be placed onto the particle based on where the pivot point of the geometry is, and that pivot point will be locked onto the world position of each particle. And world position is an attribute that all particles have by default, which is the XYZ coordinate in world space where that particle is. But everything else is not mapped. Well, the next thing under position is scale, and that says none. Well, if you're familiar with creation and runtime expressions for particles, ideally what you'd like to do is write a creation expression on scale so that your particles get a random scale at birth that they use for the size of each one of those pieces of pixie dust. So if we jump back to Maya and we select the particle object, well, first off, if we go to the outliner, we have the particle object as well as the instancer. If we go to the attribute editor for the instancer, what you will see in here is just what we saw in these top sections as far as how the rotation is handled and level of detail and which objects are instanced. But all of these attributes down here are not on the instancer node. They are actually on the particle object. And so now I will select the particle object, the one being emitted from our Omni emitter, go to the attribute editor, and you will see that on this particle object is a folder which is called Instancer, Geometry Replacement. If we open that up, we will now see all of this stuff. All of those things that were mapped to a value of none, except for position. At the top it says Instancer Node, Instancer 1. That's because a particle object can have multiple instancer nodes associated with it. So I could replace each particle with a tank as well as a piece of pixie dust. Or I could replace each one, with a variety of pieces of geometry which represent boulders or debris or asteroids, whatever. So at this point, if I go in here and look at the things we want to map, we see scale. If I click on scale, what you will notice is you get a pop-up, but the pop-up that we get does not list anything that makes sense in the sense of saying scale. And now the pop-up menu says acceleration, force, position, ramp acceleration. That's because these pop-up menus are just going to list the attributes that the particle object has by default. And so for where it says scale, I cannot right-click on it and write an expression. You have to select from this list. And this list is just listing all of the per particle attributes of this particle object, which are vectors, because scale is a vector. It has 3 components, x, y, z. And so it's going to list everything that's a vector. So since we don't see anything in here that necessarily makes sense, we could choose, let's say, velocity. And then what's going to happen is that these paint effect strokes are going to non-proportionally scale themselves based on what direction the particle is moving. So you will notice that they are different sizes now, but it's just based on the fact that they're moving at different speeds. But let's say we don't want that. We just want them to have a different size, where some are small and some are big. What you need to do is you need to go to the per particle array attributes folder and also the add dynamic attributes folder. And you need to add a custom attribute where you can write expressions on that custom attribute, and those expressions can then be plugged into the instancer settings. And so if I go to where it says add dynamic attributes, I'm going to click general and go to the first tab. Now in this first tab, what it's going to look like, and let's take a look at that. And so I'm going to get this open, is it's going to ask us what type of attribute we want to add in this window. And at the top it asks you for an attribute name. So the attribute name we would want to specify is going to be custom scale. Then in here it says make attribute keyable. Yeah. Data type. Well, if we're doing something like scale, we would choose vector. Then it says attribute type. Well, we want to set a per particle array attribute so that each particle will have its own vector attribute called custom scale. So going back to Maya, in here I'm going to write attribute name custom scale. And then for the data type I will choose vector. For the attribute type I will choose per particle array. And I will turn on add initial state attribute, that little checkbox. And I will now hit add. Now if I look inside my per particle array attributes folder, we will see I have a line item that says custom scale. If I right click on that, I can write a creation expression. And what I'm going to write is, if we go and jump out into, let's say, Notepad, particle shape 1.custom scale equals, well, remember that scale is a vector. So if I wrote in here, let's say 1, 1, 1. That just means that each particle is going to have the same exact scale of 1 and x, y, and z. So if I went and pasted that out here and hit create, I now have a creation expression on custom scale. Well, I can now move up to my instancer folder, and where it says scale in my pop-up menu, I can now see that custom scale is listed. And so since I have added a brand new vector attribute to my particle object, it'll now appear in this pop-up list of vector attributes. So let's now choose custom scale. Well, if I hit play, they're all going to be the same size because of that expression that I wrote. But if I go to the expression editor, and where it says custom scale equals 1, 1, 1, let's say I wrote in 0.2, 0.2, 0.2 instead, and hit edit, and hit play. Now notice that they're really tiny. And so you can see that our expression is actually controlling how our instance particles are being handled. So if we want them all to be a different size, what we would need to do is edit our expression. I could write something like this, equals rand 0.2, 1, and then repeat that. So if I go in here and say copy, and then paste that, so that this is now my expression. the thing, or the issue with this is, let's go and copy this and paste it in Maya and see what happens. So I'll go into my creation expression, paste that, edit, and hit play. We will see that they are different sizes now. We have some small ones and we have some big ones. But if you tumble around, they are not proportionally scaled. And the reason is because if I go into a notepad, the x value is going to get a random number between 0.2 and 1. So the x value might get something like, 0.5. But then when it gets to the y attribute, it's going to calculate this rand function differently. So now it might get, 0.2. The next one could get 0.63 or 0.6 whatever. And so at this point, we'd end up with particles that are non-proportionally scaled. If you want your particles to all be different sizes, but you want them to be proportionally scaled, what you would need to do is write something like this. We would need to create a custom attribute or variable, and that custom variable will get this rand expression on it. And then what I will go in here, and this can be called whatever you want. So I'm creating a new variable called whatever. So float space $ whatever. I could call it foo. Doesn't matter. Equals rand 0.2 comma 1. Then I could go in here for my expression and write custom scale equals foo, comma, foo, comma, foo. So therefore, we can see that the x, y, and z components for our vector, for our scale, are all going to get the same number. So we'll get proportional scaling. But the thing is that this is a per particle expression. Each particle has an attribute called custom scale. Each particle, therefore, when it's born, will create this variable, assign it a random number, and then place that same random number into the x, y, z positions of the vector for its custom scale attribute, which is plugged into the scale on the instancer. So now let's go in and copy this, paste that into the instancer, and now let's go back and hit play. And we will see that some are going to be big and some are going to be small, but they are all going to be proportionally scaled. And so if we go in here, we can see, regardless of which angle we look at it from, we are getting this proportional scaling. Now they are all oriented the same way, but the thing is that even though they are oriented the same way, they are different sizes. So if we go in here now, we can render that and see what happens. So now that we've seen an example of scale, let's move on to another example where we deal with rotation as well as scale. So I'm going to make a new scene, and this time let's say we deal with something like we're trying to do an asteroid belt or a meteor shower or something like that. So we need to create some asteroids that we want to instance. Or maybe we're going to try and create an explosion where that explosion has some debris in it. And so for something like that, if I, let's say, get this little movie to open, what I have is a sort of a explosion where we have these boulders or big pieces of debris that move out. And those are done using the instancer. But the thing is that for this example, I am using the same piece of geometry, instance onto each of those particles. But what we can see is they're all different sizes, and they are all oriented differently. And so notice that when I hit play, they're also rotating. And so as this plays through, they're actually rotating and orienting themselves around. So if I move out here and actually load that in, and go back to frame 1 and hit play, so notice that each one of those are actually spinning around. But they're all spinning around in different ways. They're not all rotating around the same axis. So for something like an explosion where you'd want to have debris, it doesn't have to be rocks. Obviously, if you're having a building explode or a tank explode or whatever, you might create a library of pieces of geometry that represent different types of debris and instance those onto your particles. So at this point, what we're going to do is, let's say we go in here and make a new scene. The first thing that we're going to need is a piece of geometry to instance. And so again, we're going to start with just having one object. And for that, I'm going to go in, and something that's useful is I could just load in a piece of geometry, but there's a script that's kind of neat for creating things like asteroids or meteors, boulders or whatever. Let's say you're doing a landslide. And it's a script that you can get at high end, or you can grab it from the Gnomon Workshop site. which is called rock generator or just rock gen. And what it basically does is creates different types of rocks for you. So you get a pop-up menu, so I can choose boulder, and if I hit generate, you'll see that I get this randomly created piece of geometry. If I hit generate again, we get a different rock. If I hit it again, a different one. Every time I hit generate, I actually get a different looking boulder. Now if I go to the pop-up and change it to glacial and hit generate, now we get these rocks that look more like glaciers. So I can move these around. If I choose something, let's say like slate, now we're going to get these very flat objects that have a little bit more variation on their edges than they do at their center. So if we close that, you can see I now have this very quick library of rocks and boulders and whatnot that were created just using that rock gen script. And they're polygonal objects. And then obviously you can go and scale them or non-proportionally scale them yourselves to create whatever kind of boulder you need. So if I go in and just create one, so we'll go to rock gen and we'll create a single boulder. And let's close this out. And let's scale this up a little bit. Okay, so that we now have this one boulder. First thing I'm going to want to do with this boulder before we place it on the particles is I'm going to want to center the pivot point on it. So I'll go to modify center pivot, so that when this is placed onto the particles, I know that it's going to be placed based on where that pivot point is. Then I'm going to move it to the origin, 0, 0, 0, and then I will take that boulder, I'm going to make it a little bit smaller, and then I will freeze transform it. And let's throw a quick shader on it. So I'm just going to go into the multi-lister and create real quick a Lambert shader that I will assign to that object. And let's assign a file texture to that. And so let me grab, let's say, a texture of rock. Okay, so now we have this rock texture on this boulder. And we can see the UVs aren't necessarily laid out very well. And so I'm going to select that object, and in modeling mode, I will just go to texture and do a quick spherical map on this boulder, and then delete history on it one more time. So that now we have a simple rock, and we want to get that onto our particles. So we need a particle object. Go to dynamics mode, create emitter. We got an omni emitter. For the omni emitter, it's emitting particles. The particles are hard to see, and so we're going to grab those particles and get them to be spheres. Now that they are in sphere mode, let's make them a little bit smaller. And then for the emitter, we have way more than we need, so I'm going to lower the rate down to 2. So we're just getting a few that are coming out of there. So in here, we now want to get that rock to be instanced onto those particles. And so I will select the boulder, the piece of geometry, and I will go to the particles pull-down menu, go to the instancer, and then I will leave everything at the defaults and hit create. Now when I hit play, we will see that we've got this boulder instanced onto each one of those particles. But they are all exactly the same size, and they are all oriented or rotated exactly the same way. So what we will now do is first let's get the scale to vary. I will select the particle object and go to the attribute editor. What we need to do to control scale, like we just did before, is we need to add a custom attribute, which we will call custom scale. So add attributes, general. I will call it, you can call it whatever you want, but I'm going to call it custom scale. It's going to be a vector per particle array. Hit OK. Now I will go in and right click on that and write a creation expression. And so I will do the same thing that I did before, so that we have that custom attribute that gets plugged into, or that custom variable that gets plugged into the scale. So if I go in here and copy this, and first let's say we do something that looks like this. Custom scale equals, let's say 1, comma, or let's say 0.3, comma 1, comma 0.3, and hit create. And then I go to the instancer folder, and where it says scale, we choose custom scale and hit play. Notice that they are all now scaled vertically in Y. So they all still look the same, but they're all getting the same setting. And then if we went in and edited our expression, let's say we didn't do a creation expression. Let's say we did a runtime expression. I could go to runtime, custom scale, equals and I could do something where it's 0.2 comma time comma 0.2. If you do that in a runtime, what's going to happen is these objects, notice that they are scaling in y. They're getting bigger. So you can use runtime expressions. Well, for our scale, we're going to want to use creation. But when we get to rotation, we'll start playing with runtime. So let's go in here and delete that expression. Go out to Notepad. Grab the expression which has the custom variable. Paste that in here. Enter that. And now hit play. And now notice that we have some small ones and we have some big ones. So you have to decide by editing your expression what the range is of scale that you want. So maybe 1 is too big. Maybe I'll put 0.2 comma 0.75. Edit that expression, go back to frame 1 and hit play. And so now we're getting our variation in size. Some are big and some are small. So this is the first step that you're going to want to do to create variety. So if you were creating a forest of paint effect strokes, you might want to use a library of 5 trees or 10 trees, but then by having them all be scaled to different sizes, you can make those 5 trees look like a larger variety. So here with just the one, we're seeing something like that. But now we need to talk about rotation. Well, if we select the particles and go to the attribute editor, what you will be able to see in here, and let's actually just jump it back over here. So I'm going to open this up so that we can see the creation or the instancer settings. And we've talked about scale. It should be pretty clear what shear would do and what visibility would do. So again, with either shear or visibility, you could create a custom attribute that controls how the shear changes or how the visibility changes on this particle object. You have an attribute then called object index. We'll talk about that later. That has to do with how you can select from a library of objects. And then we have our rotation options. There are several different settings in here for rotation that we're going to need to talk about. The first one is rotation type, and then we have rotation. The one that's going to be intuitive to you, the one that handles rotation from a straightforward XYZ point of view, is the one that's called rotation. So if you wanted to write, let's say, creation expression so that each object gets a different rotation in Y, you would just use this one, the one called rotation. But if you want to be able to, let's say, have the objects aim themselves based on what direction they're moving in, or maybe each one of your boulders, instead of doing boulders, maybe you're doing arrows that are shooting through the air, or a rocket, or a plane, or a spaceship, or whatever. And you want those to orient themselves based on the direction that the particle is moving. That's when you might use aim direction, or aim position, and all of these different settings that we have that have to do with aim. But for these boulders, for these meteors, we're just going to focus on the rotation for now. So let's go back to Maya, and we're going to want to go down to the custom attributes section and add a custom attribute called custom rotation. So custom rotation. It's going to be another vector per particle array because rotation is a vector. So I'll hit add, and now we can create expressions again. If I go in here and write a runtime expression, I could go and have each one of these objects be spinning on a single axis. So let's say we go in here and we do something like that. I'll say that particle shape 1, let's go over to Notepad for a sec. I can say that particle shape 1.custom rotation equals 0, comma, time divided by 50, comma, 0. That basically means that these objects are going to rotate in their y-axis. So they're not going to rotate in x or z, but in y they will start to spin because I'm going to enter this as a runtime expression. So let's go in here to runtime, hit create, and now I'm going to go in and hit play. So let's close this out. And when I hit play, what we will notice is first I need to then go up here to my instancer folder, and where it says rotation, I need to click on that pop-up list and choose custom rotation. You can't forget to plug them into each other. And now when we go back to frame 1 and hit play, there you go. Notice that we now have these spinning boulders. They're all different sizes, but they are all rotating on their y-axis. Now, it doesn't look very natural in the sense that they are all rotating exactly the same because they are all getting the exact same expression where they're all rotating based on time. Well, let's say we go back in here and we want to sort of get it to be more natural. So I'm going to go in. First, let's hide our original boulder. We don't need to be looking at that anymore. So display, hide, selection. Go back to frame 1, hit play. Let's select the particle object. Go to custom rotation. And first, let's get rid of that expression. Well, maybe you don't need those objects to rotate. You just want them to be oriented differently because you're trying to create like, an asteroid belt where they don't necessarily need to be rotating. They just need to be oriented differently. What I will go in here and do is modify my expression. So I could say that my particle shape 1 dot custom rotation equals, and let's get rid of this previous one, and then rand, let's say we first do like 0 comma rand 360 comma 0. That's just going to mean that each meteor is going to be oriented, or boulder is going to be oriented differently at birth on its y-axis. So if I enter this as my creation expression for custom rotation and I hit play, if you look from the top view, you will notice that each one of these boulders, they're not rotating, but they are all oriented differently along their y-axis. If we wanted them to be oriented differently on their x, y, and z axes, I would edit the expression so that it now would read something like this. Equals rand 360, comma, and then we'll use rand 360 for all three attributes. And so this way, if I go and enter this, comma, enter it again, this is something that for scale we didn't want to do because we wanted them to be proportionally scaled. But for something like rotation, it's okay because we want them to just be oriented differently. So I will go in here, copy this, enter this as my creation expression for my particle rotation, hit edit, and now let's go in here and hit play. And there you go. Now we have boulders that are all different sizes, but they are all oriented differently. So for something like an explosion which has a bunch of debris in it, you could see that this would be useful. So I could go in here, grab my emitter, let's say go and set stepped keyframes. So maybe I've got a rate of 5 at frame 1, but then maybe at frame 20, the rate goes to 0. And we'll key that. And if I hit play, we're just going to get this little burst. Let's go back to frame 1 and edit it so the rate is a value of like 100. And reset that key and hit play. And now what you can see is that we're just going to get this sort of burst of these boulders. But then as time goes by, you'll notice the emitter is no longer emitting particles into that particle object. We're just getting this burst, and they are all oriented differently. They're all scaled differently. So even though they're all the same boulder, it looks like we actually have a few of them. And so you can imagine that if you combine these techniques with a library of boulders, you can really create and get a lot of variety inside your particle instanced object. Now let's say we wanted them to all be spinning. Instead of them all to be static, we want them to all be rotating or tumbling around like you would expect debris to be doing in an explosion. What I'm going to do is let's go in here and edit our expression so the rate is not quite so high. And so let's get that back down a little bit. Let's hit create. Okay, so now we have our little burst, but they are not rotating. What I'm going to need to do is select the particles and go out here and write expressions again. What we basically need to do is we need to write both creation as well as runtime expressions. And so this is going to get a little bit more involved. What we need to do is we need to have our particles, we want them, so our goal in here is we want all of our particles, so all particles must rotate differently, but we want all the particles to rotate, so some rotate, let's say, in positive, x, y, or z, and some rotate in negative x, y, or z. And so that's kind of what we want. So some are spinning around, and in their x, y, and z, they might be rotating positively in x while rotating negatively in y. You might want to do something like that. But either way, that's the kind of thing that we'd want as a runtime expression. So the way that you could do something like this is you'd want to combine a creation expression with a runtime expression, where your creation expression says, all particles are oriented differently, kind of like what we just did. But then our runtime expression is going to say that all particles then continue from where they were at birth. So that, if they were all given let's say one of the particles was given an X rotation at birth of 55. And a runtime, once you hit frame 2, you want it to continue from that rotation of 55 and start rotating in a certain direction. So continue from their birth rotation. And so then the next thing is, well, you want some to rotate faster than others. So some are spinning slowly and some are spinning fast. So the next question is, how do you create that variation where some are doing that? What you can do is have a variable or an attribute that each particle has that gets a random number in a creation expression. And so in your creation, you want to edit it even more so that you've got some random number assigned to each particle, and then in the runtime, the random number is used to determine rotation speed. So the random number is assigned at birth, but then used in a runtime expression. So it's a little involved, but let's go and do it. For that random number, I'm going to want to assign that somewhere. The way I'm going to do it is I'm going to add a new attribute, which I'm going to call random whatever. We'll just call it rand, or random attribute. Or we'll call it random number. So random underscore number. For this random number attribute, it's not going to be a vector. It's going to be a float. So this attribute's called random number. It's a float per particle array add. For our random number, we're going to write a creation expression. And so the creation expression we're going to want to write, let me go in here. Let's go back to Notepad. And we're going to do this. Our creation expression for our random number is going to be this. And so particle shape 1 dot random number equals rand. And then if we put negative 5 comma 5, some particles at birth are going to get a negative number. Some particles at birth are going to get a positive number. And then that will determine, by using this number in the runtime, whether they rotate clockwise or counterclockwise. Now, when you're dealing with rotation on the instancer, if you want them to rotate slowly, you have to use very, very small numbers. So what I'm going to do is say rand negative 0.001, comma 0.001. So it's still going to be negative to positive. It's just small numbers. And then in my creation, I'm going to say particle shape 1 dot custom rotation equals, and again we're going to do the vector where we have rand 360 comma rand 360 comma rand 360. Okay, so this is our creation expression. So let's copy that and paste that in here. Edit. And so now with this creation expression, we don't have anything in runtime right now. So if I hit play, it's going to look the same. We just have these boulders and they're all rotated differently, but they're not spinning. And so, but we do know that this random number attribute, the attribute that's called random number, now has been given a random number between negative 0.001 and 0.001. Now when we go to our runtime expression, what we want to do is we're going to utilize that random number within the expression. And so we're going to go and say particle shape 1 dot custom rotation equals, and instead of doing equals, we're going to do a plus equals, meaning that they will continue from where they were at birth. And then what we're going to do is choose the particle shape 1 dot custom, or the rand number, or so random number. So let's go in and choose this. Copy, paste. And so if we go in here and make the font a little bit smaller so everything fits on single lines, that's what we're doing. So particle shape 1 dot custom rotation plus equals particle shape 1 dot random number. So that random number is being added to each one of those. But if it's a negative number for an individual particle, instead of being added, it's going to be subtracted. So if we now take this runtime expression, copy that, and paste that as our runtime, and hit create. If we now hit play, we're going to see this. We now have spinning particles. Some are spinning slowly, some are spinning fast. And the most important thing to point out, let's go out here and play this back, is the fact that it looks very random. So notice that some are spinning quickly, some are spinning slowly, and they're all spinning around a different axis, which is the way you might expect debris to behave in an explosion. And so this might seem a little convoluted in the sense that there are a lot of things I needed to explain in there to do something like this, but it's obviously pretty important thing to know as far as using a custom variable to define a random number that is then used in a runtime expression to determine rotation. And so if we then take a look in here one more time, let's grab the particles. If you decide that they're rotating too quickly, all I would need to do is go to my random number. And so let's actually go into Notepad. And instead of it being negative 0.01 to 0.001, I could say, negative 0.0005. So they're really tiny numbers, but you can see they actually make a big difference. And so at this point, this is just going to make them rotate slower. If I want them to rotate faster, instead of 0.001, I could say, let's say 0.01. That's going to make them go 10 times faster. And so let's go out here into the expression editor. So edit that so that it's 0.01. Hit edit. Go back to frame 1 and hit play. And now you can see they're spinning really fast. You still have one that are spinning really slowly because it's generating these random numbers. But this is a little bit too fast. So you can see why the 0.001 that I used tends to look a lot more natural as far as a range that you want. And it's very important to also understand, by looking at the expression, that we still have our custom rotation getting a random X, Y, and Z orientation at birth. And then this random number. And then the fact that we're using a plus equals there so that they continue from where they were at birth, so they all rotate in a different way. And so with all of this stuff entered in here, we now have a pretty straightforward debris type of explosion. So it doesn't have to be boulders. It could be chunks of wood and metal or shards or shrapnel, whatever it is that you're trying to do. We need to learn how to select from a library of objects. So that's going to be what we're going to talk about using, let's say, an example where we deal with some rocks first, and then we can look at some paint effect strokes. And so if I open a scene that has, let's say, 6 different rocks. Each one of these rocks I created just using the rockgen script. And what we're going to want to do is create some particles. And so what I'm going to do is I'm going to use the CV curve tool and just create a curve that I will turn into an emitter. And basically we'll create a quick asteroid belt. And so it's going to be a curve emitter with a speed of 0, max distance of 5 units, no directionality, and I'll hit create. And when I hit play, we're going to get a bunch of particles. But what I'm going to do is keyframe the rate of my emitter so that it only emits particles for about 10 frames. And so let me hit key there. And so when we go back to frame 1 and hit play, we'll be able to see that we do get a few particles. They're hard to see, so of course let's make them spheres. And if we decide that that's not enough asteroids, all I need to do is grab the emitter and rekey it so that maybe its rate is, let's say, 250, and set a key. So that now when I hit play, we can see that we get, a bunch of particles. So this can be my, asteroid belt, and so I need to get those 6 rocks or boulders or asteroids or whatever to be placed onto the particles where they all have a different orientation, a different scale, and then also they're randomly chosen to be placed onto the particles. For something like this, what you would do is you still need to select the geometry and go to the instancer, but first you'll just select them by just selecting all of them. The order that you select them does not really matter. It depends what you're trying to do, but if you just want to randomly place these rocks onto the particles, you can pick them in any order. And so I'm going to go in here. This one on the left is a little bigger than all of the other ones, so I'm going to scale it down a little bit so they're all about the same size. So now I will select them, and with them all selected, I will now go to the instancer, and in the creation dialog box, I'll hit reset, and we can see that now where it says instance objects, it's listing all 6 of those selected rocks. At this point or later, you can see there is an add selection or remove items button. So I can add more elements to this list at any time, or I can remove some by just selecting them. And then there's also move up and move down. That's to change the order that they're listed. But like I said, right now we don't need to worry about that because we're not dealing with sequencing or cycling through the list. And so with all the default settings, I'll hit create. So when I hit play, obviously we're going to get the exact same rock placed on each particle, and they're all the same size and oriented the same. So to now go in here and change which rock is being used for each particle, what we will need to do is select the particle object, and you will see in the Instancer folder there is a attribute called object index. By default, that has a value of 0, which means that it uses the first object in the list. So when you have 5 or 6 objects like we have right now, the first object in the list is considered to be object 0. The last object in the list, when you have 6 objects, is going to be object number 5. And so what we're going to want to do is write a creation expression for object index so that not all of the particles are getting the same object index number. So to do that, like we did with scale and rotation, we have to add a custom attribute that we map to object index so we can write a creation expression. So I'm going to add a new attribute, so add attribute, which I will call custom underscore index, which will be a float per particle array. And then when that's added, I will write a creation expression so that particle shape 1.custom index equals rand 0, 6. So it's going to be rand 0, the number of objects that you have in your list. Because even though the object index list goes from 0 to 5, when you do a rand, it rounds down. So if it returns a value of 5.6, it'll return a value of 5. So you want to do rand 0, 6, not rand 0, 5, so that all objects in your list have the same likelihood of being selected. So I'll hit create, and then I go up here to where it says object index and choose my custom index attribute. And now if I go back to frame 1 and hit play, there you go. So you can see how easy it is to get all of our objects to be randomly selected and placed onto our particles. And now automatically we have a quick little asteroid belt. The only thing is that all of them are the same size and they're all oriented the same way. To change that, we have to do what we've already done, and so we'll do that kind of quickly, is I'll go in and I'm going to add 2 attributes. Custom underscore scale, which will be a float, and custom underscore rotation, which will be a vector. I made custom scale a float because I want them to be scaled proportionally. So the expression that I will write on custom scale is going to say equals, let's say rand 0.5, 1.5. And then for my custom rotation, and so let me go in here and do custom scale again because I forgot to hit edit. So equals rand 0.5, 1.5, and then enter that. And then for custom rotation equals, and then this is a vector, so rand 360, and then rand 360, rand 360. And so if we went and took everything that I just wrote, and this is all creation expression, or these are all creation expressions, we can see what I've written. And so custom index, custom scale, and custom rotation with the values that they're getting. And so now if I hit edit and go back to frame 1 and hit play, what we can now see is we have to also remember to map these attributes up here. So where it says scale, I want to map that to custom scale. It's not listing custom scale because custom scale is not a vector. So we have to check allow all data types. And now scale gets custom scale, rotation gets custom rotation, and then now I can go back to frame 1 and hit play. And now we can see when we move in here that they are all different sizes and they are all oriented differently. And so it increases the amount of randomness that you have inside this asteroid belt. And when you are using a library of objects, Maya will allow you to use motion blur when you are using static objects that are being randomly selected from. And so we could have an asteroid belt that we are flying through and get the appropriate results. And obviously they'll all be able to cast shadows and stuff like that because of the fact that instance geometry can be reflected, refracted, and can cast shadows. Another thing to point out is the rocks that I'm using right now are relatively low res. And you just have to be careful. Maya will allow you to use as high res as you want geometry to place on the particles. It's just remember that things will get kind of slow. And so you may choose, if you have a situation where your camera is going to be, let's say, positioned over here, where you have low res geometry used for the particles that are far away, and then higher res asteroids for the particles that are closer. And so what you could do is for your object index, you could write expressions so that maybe like the first 3 objects in your list, maybe these are low res rocks or asteroids. And then maybe the next 3 objects are high res. And then you could write an expression on that custom index attribute that queries the distance of a particle to the location of the camera. So that if the distance of the camera between the camera and a particle is greater than a certain amount, then it uses objects number 3 through 6 in your object index list. And so it's just a matter of writing conditional expressions to select which objects are used from your library. So now that we know how to select from a library of objects, let's say we were going to go and, if we did something like the pixie dust example before, you can see that that would be just as easy as this was of having multiple strokes. But remember the whole thing of having these objects be at 0, 0, 0 when they're at the origin. And so any one of these rocks, if I select them, if I enter 0, 0, 0 for their translate XYZ values, they all go to the origin. So if I now open a scene where we do have, let's say, a paint effects example where we want to create some trees that are placed onto, let's say, a ground plane. In the scene that I'm opening up, let me get rid of the instancer and the particle object so that what I have in here is I'm going to get my paint effects strokes to be visible, and I'm going to hide the ground plane, and I'm going to hide the image plane. So I can see in here that I've got 5 different paint effects strokes that are sort of situated around the origin. Now if I select any one of these trees and I enter a value of 0, 0, 0 for translate, you can see that that tree went to the origin. So if I went in here right now and did a quick render of just what we have, we're just going to get our image plane with these paint effects trees on top. But if we want to take a look at what things are going to look like once we get the paint effects trees onto our ground plane, let me give this a couple seconds to render. So there's our paint effect strokes. And let me go and actually open the render view window again. Let's get it to be a little bigger. And I'll load in an image which already has the paint effect strokes placed onto our ground. So you can see that we have these different trees placed in strategic locations, and they're different sizes, they're oriented differently and whatnot. So to do this, what I'm going to need to do is first create my particle object. So I'm going to select the ground plane, make it visible again, and then what I want to do with my ground plane is create some particles. I could do this in a couple ways. I could use emission, or I could use the particle tool and make the surface live, which is what I'm going to do now. Emission just means that this surface could be an emitter, and you could use a grayscale map to determine where the particles emit from, and you just give them a speed of 0, so that when they're born, they just pop on the locations on your grayscale map that you wanted your trees to be. But to use the particle tool, I just need to select the ground, make it live, go to the particle tool, and then what I'll do is I'll just start clicking and these sort of like elevated flat areas on the ground, so that's where I'm going to get my different trees. And so let me just place a few of these down so that sort of on the border perimeter of this plane we'll get some trees. So I've clicked a few. We're going to get about 30 of them. I'll hit enter, and now we'll delive the surface, and if I select my particles, I'm going to make them spheres so that we can see them, of course, and we'll make them a little bit smaller. And so now wherever I have these little white dots, those are my particles, and that's where I'm going to get some trees. So what I now need to do is I'm going to select all 5 of my paint effect strokes. And remember, you want to select the stroke, not the NURBS curve that's associated with the paint effect stroke. So I select all 5 of those trees, and then once they are selected, I go to the instancer, go to the creation dialog box. Everything's at the defaults. It's listing all 5 of my trees, listed as item 0 through item 4. I will hit create, and now what we will see is that my particles are all getting that first paint effect stroke, which is a very hard to see little line. Well, now what I'm going to do is select the particle object, and add that custom attribute. So I'm going to add custom underscore index, which will be a float. And then I will write a creation expression so that custom index equals rand 0, 5, because I have 5 objects in my list. Hit create. And now I will go to the instancer folder and map that to object index. So object index gets custom index. And now automatically you can see I have my 5 different trees mapped onto these particles. The only thing is they all are exactly the same size and they're all oriented the same way. So to change their scale, as we know, I just need to go in and add custom scale, and for the rotation I'll add custom rotation. So let's go in here and say custom scale, which I will make a float so that they're proportional, and then custom underscore rotation, which will be a vector. For custom scale, I'm going to write a creation expression so that they equal rand 0.5, 1. And then for custom rotation, I don't want them to be rotated in all 3 axes. I just want them to be rotated in Y. And so what I'm going to write is that the custom rotation equals 0, rand 360, 0. So that each tree just rotates randomly on its Y axis. And so if I now go and let's say we paste that out here, you can see what I've just written. So my custom rotation is 0, rand 360, 0. So now that that expression has been entered, if we go back in here, I'm going to hide my original strokes, which are sitting at the origin. So display, hide, selection. And now if we tumble around, we'll be able to see that I've got trees all over the place. They are all different sizes, and the fact that they are also orientedly differently on their Y axis. The performance is not very good as far as tumbling, and so I would select my instancer node, go to the attribute editor, and set the level of detail to bounding boxes. And so now you can see that I can tumble around very quickly as I move through here. Because if you were doing something like a forest, obviously it would get really, really slow if you had a lot of trees. But once you're in bounding box mode, it's in real time. It's just your render time obviously will slow down if you have a lot of paint effect strokes. That's just the way that goes. But as far as interactivity, which is the most important thing, you can see in here that the interactivity is fine. So that's the basics of choosing from a library of objects. Now we need to start talking a little bit more about some of the rotation settings that we have other than the default rotation attribute. So I'm now going to go and make a new scene, and we'll get into that. The scene that will open up so that we can demo what the rotation settings do is if I open up, let's say, this little rocket that we have. It's multiple components that are grouped together, so I'm going to select the root. I'm going to scale it down a little bit, and I'm going to also create a plane which I'm going to turn into an emitter that's going to be emitting these rockets. So let me turn that into a surface emitter. So emit from object. I'm going to hit reset, surface. I'm going to lower the rate down, hit create, and then I'm going to grab this plane and let me just rotate it and move it to the side. So that now that we have this plane that's going to be emitting these rockets, let me up the tessellation on that. When I hit play, I'm going to get some particles. For the particles, I'm going to go and, let's say, turn them into spheres. And then we're going to want to take these particles, connect gravity to them. And then also I'm going to grab the field and increase its speed, let's say to a value of about 15. So that now when I hit play, I can see that these particles are being shot out. Let's try a value of 25. So they're being shot from the plane and then falling with gravity. But now I want my rockets to be there. Remember that the rocket's going to be placed onto the particle based on where the pivot point is. Right now the pivot point is at the center of the rocket. If I wanted this rocket to have a smoke trail coming behind it, you might do that by selecting the particles and also having those be emitters. But in that case, if you want the smoke trail to be coming from the end of the tail of the rocket, what you'd want to do is take your rocket and move its pivot point to the tail. And so at this point, if I now move the object to the origin, I'm going to need to freeze transform it so that it's at 0, 0, 0 at the origin, pointing down the x-axis, and the pivot point is at the tail. With that done, with that rocket selected, I will now go to the instancer, hit reset, hit create, and then what we will now see when I hit play is that if we look to see where the particle is, you can see that the particle is at the tail of the rocket. And so now the issue is that these rockets are not rotating with the direction that they're moving in, which is what you would want. Well, that's why we have a lot of rotation controls other than the default rotation setting that we've been using. So if we go back out here and look at this image, we'll see that where it says rotation options, we've already used rotation, but we then get aim direction and aim position. For aim direction, it's very common that you will change that. And what it's going to mean is if I go into the Instancer folder, and let me just close some of these things out. In the Instancer folder, aim direction, if I go to the pop-up, there's an item called velocity. It's very common to map velocity to aim direction, because what's going to happen now is this. Notice that those rockets are now rotating based on the direction of movement. And so this is just a matter of going in and setting in the aim direction set to velocity. So if I now went in here, I could also go and grab my particle object, which is the emitter, select that particle object, and say emit from object again, and this time maybe I'll choose Omni. Hit create, and then if I go into the outliner, select that particle object, maybe I will make that particle object multi-point, color accumulation, opacity per particle, map that with a ramp. And if I go in here and hit play, we're going to see that we're going to have a trail, or a rocket trail, coming from the tail of each one of these rockets. But since the particle is located that's emitting those particles at the tail, we know that those smoke trails are coming from the correct location from each one of these rockets. So now the aim direction is not the only attribute that you have inside there. So let me delete that particle object real quick so that we're just back to having the rockets. If we select the particles and move out here, you also have something called aim position. Now we already know what rotation is. We used that before with the boulders and the trees. Aim direction we just used and mapped that to velocity. Aim position is a position in world space that the particles are going to point to. An important note is that you can only use one of these at a time. So rotation, aim direction, and aim position, you can only use one at a time. Whichever one is mapped, if all three of these are mapped, it's going to use the first one in the list. So that if we go in here and map rotation and aim direction and aim position, it's going to use rotation. First, let's see what aim position does, though, before we talk a little bit more about that stuff. And what I'm going to do is I'm going to create a custom attribute, which is a vector, called custom aim position. I'll hit add, and I will write an expression so that custom aim position equals 0, 0, 0. Hit create, and now I will map my aim position. I'll put aim direction back to none, but aim position I will map to custom aim position. And now when we hit play, you will see this. Notice that the rockets are now pointing to the origin. So aim position is a position in world space that the objects will aim at. And so one of the questions that you might have is what's determining how they're aiming? Well, by default, like I've pointed out, it uses the x-axis as the aim axis, the y-axis of the object as the aim up axis, and then the y-axis of the world as a default world up axis. And so that's why I said to make sure that your objects are pointing down the positive x-axis. Okay. So if I select the particle object and go back out here, you'll see that you do have controls in here for aim axis, aim up axis, and aim world up. You'll never really need to touch those if you make sure that your object's pointing down the x-axis and that its up axis is its y-axis. But if you decide that you want the z-axis of the object to be the aim axis, you can go and map vectors to aim axis, aim up axis, or aim world up. Also inside here, we have an attribute called rotation type, which is set to none by default. That has a value of either 0, 1, or 2. That determines on a per particle basis, if you write an expression, which of these three are going to be used if you map rotation and aim direction and aim position. So if I go back out to Maya, if I set that aim direction equals velocity, and then I say that rotation, maybe I go in here and write a custom underscore rotation, and then I make that a vector, and then for custom rotation I write a runtime, so that custom rotation equals 0, time divided by 50, comma 0, so that these objects are going to spin on their y-axis. I will map that to their rotation. When I do that, what's going to happen is that all of the objects are going to spin on their y-axis, even though I've also mapped their aim direction and aim position. But if I then go in here and add another attribute, which is a float, called custom rotation type, hit add, but then I write a creation expression. So custom rotation type equals rand 0, 3, enter that in there, and assign that to rotation type. What's going to happen when I hit play is some of the rockets are pointing to 0, 0, 0. Some of the rockets are moving with their aim direction, and some of the rockets are rotating on their y-axis. And so you can see that it's randomly selecting for those rockets between rotation, aim direction, and aim position because I mapped rotation type. So that should give you an idea of all of the different rotation settings that you have to control how these pieces of geometry are going to be oriented onto those particles. So it depends on what you're doing. So for something like rockets, you're just going to say aim direction equals velocity. For something like spiders crawling along a surface, you'd say aim direction equals velocity. Or robots walking around a ground plane. So the next thing we want to talk about now that we've seen these things oriented is, let's say I go and make a new scene. Now we need to start talking about putting animated objects onto particles. When working with animated geometry, there's two ways you can approach it. One is, if we take a look at this scene where I've got a butterfly flapping its wings. If I look in the outliner, we'll see that I just have a single group node. So the butterfly is comprised of separate pieces of geometry, but then they're all grouped together, and all of the animation is underneath the top node. So I can select that top node, see the butterfly is pointing down the x-axis, but I do not have any animation on that top node so that we can control the rotation and the scale and those things using all of the instancer attributes. So you want to leave that top node clean. And so for this butterfly, what I have is I simply have animated the wings where I've got 20 frames of animation. So I have keyframes on the wings at frame 1, frame 10, and frame 20. And then the keyframes on those wings in the graph editor I have set to cycle. And so automatically the curves cycle. So if I go and, let's say, set my time slider to 500 frames, that butterfly flaps forever. So you can instance animated geometry onto particles where you just grab the group node and go to the instancer. And so if we open a scene where we have something like that, what we will see is in this scene, I've got some particles that are being emitted off of a plane, and then you'll notice we have all of these different butterflies. Well, if I went into this scene, first of all, this is the corresponding movie file. Let's get that to be up. Looks all right, but when you watch it for a while, what you notice is that even though it looks okay, you eventually key into the fact that all of the butterflies are flapping their wings exactly the same way. And that tends to doesn't look very natural. And so there are ways around that, but when you set things up this way, you don't have a lot of control as far as just putting an animated object directly on the particles. So if I select the instancer and delete it, instancer node, and get my original piece of geometry to come back, and take these particles and make them spheres so they're easier to see, we can see these particles are just emitting off of a plane. But let's switch to a different camera so we can take a look at our original butterfly. And there it is, just flapping its wings. So I'll just go in and grab the root node for the butterfly, go to the instancer, go to the creation dialog box, hit reset, everything's at the defaults, and then all I will do is go in here and set aim direction to velocity. Hit create, and when I hit play, automatically I get all of those butterflies. So I can now grab that particle object, get those to be points again, so they're not obscuring our butterflies. I can hide the original butterfly, so hide selection, and there you go. So it's very, very easy when you don't mind having all of the objects look exactly the same. So sometimes you can get away with it and sometimes you can't. So in this case, it becomes noticeable after a couple seconds. If we look at the case where we had the spider moving along the terrain, again, if we take a look at this movie file, what we will see is that you don't necessarily notice quite so much that all the spiders are actually completely in step with each other. just because they're moving kind of quickly and it's kind of dim. And this is something that, like I said, if you're all right with this, it's very, very easy to set up. It doesn't take very much time. But we will get into how we can go in and create variation. So for this scene, if I delete the instancer, and I'm going to hide the ground plane for a second, so display hide selection. And then let's get the spider to be visible, so display show selection. And let's switch to a different camera. When we look at our spider, we can see that we simply have an animated piece of geometry, an animated character. And for this spider, it does have skin geometry. So the legs are actually skinned and they're actually deforming. And so it's a combination of some parented geometry with some skin geometry. So when you want to instance something like this onto particles, what you want to make sure that you do is just make sure you grab the top node and group everything together. So in this case, this top node, which is called spider, if I take a look at that in the outliner, has all of the pieces of geometry that are skinned underneath it. And then it has another node, which if I open that up, has all of the IK handles, as well as the skeleton for this character. So I've grabbed the skeleton, all the IK handles, all of the skin geometry, and grouped all that together. And that top group node is what you would select to instance onto the particles. And so I will do that. I'm going to select that group node, because if I go in and hit play, what we're going to see is I've got these particles that are sliding along a surface. And so let's go and get those into sphere mode. And they're sliding along a ground plane because I'm using goals. And so you can see by having the goal V of these particles be based on a ramp, the particles move along the surface. And so all I need to do now is grab my top node for the spider, go to the instancer creation dialog box, hit reset. The only object in my instance objects list is that spider node. I will set the aim direction to velocity and hit create. I can now go and hide my original spider, so display hide selection. And then now if I get my ground plane back, so let me get the ground plane to be visible, we will see if I select the instancer that there are the spiders. And if we switch back to our original camera, we can see that we're back to where we were. So the setup is not very long. The only thing that you need to check is make sure that the speed that the particles move along the surface matches the speed that you animated the spider walking, so that the spider doesn't slide along the ground. But the next thing we want to talk about is how you can actually control the speed that the spider walks, or the speed that an object is animated, be based on how fast the particle is moving. So that if some of the particles were moving slowly, you might expect the spider to move slowly. That is something that you could do, but you cannot do it this way. So that when you just take an animated node and put it onto particles, you do not have any control over the timing. But so the way that we can go on, let's move on to the next issue then, is how you do that, is let's make a new scene. If we open up, let's say something like a different QuickTime movie, where we look at the one where we had the mechs walking over a ground plane. And so in here, that is right there. Because actually, first, if we look at this one where they're all the same, it's kind of what we just look like. They're all walking exactly in step. So even though it looks neat, it's not really very natural. While we look at this one, they're all out of step with each other. And actually, in this scene, we have a little bit of a difference in the speed at which they are walking. So first, let's talk about how something like this needs to be set up based on the initial steps you need to go through. What you need to do is, instead of having your initial object, let's say we go back to the butterfly, which is just flapping its wings, if you've animated 20 frames of this object animated, which is the case for this butterfly, and so we've got frame 1, frame 10, and frame 20 for our keys, you'd have to duplicate the butterfly 20 times so that you create a library of butterflies. And so the way that you can go and do that is either you can do it manually by selecting that top, or by selecting the geometry. So I'm just going to go in, select the surfaces for the butterfly at frame 1, go to edit, duplicate. Then what happens is all of the copies are still inside that hierarchy. So I will unparent them. And then for those unparented pieces of geometry, I will group those together. And that becomes butterfly underscore 1. And I can move that to the side. Then I would do that again at frame 2, frame 3, frame 4, frame 5, and so forth. So it can be tedious. And then you create this library. An important point, though, is the speed at which you animate the butterfly. In this case, we have a 20 frame cycle, is the slowest your butterfly will be able to move when you place it onto the particles, based on the technique of creating a library of butterflies. And so if you think that your butterfly might need to do a 5-second flap between the wings going up, down, and back up again, you would need to create 150 copies of your butterfly. Since that can be really tedious to do, there's a script that you can get at High End or at the Gnomon Workshop site, which is called Instance Copy, which was created by a Gnomon student. His name is David Parisi, who wrote it for a scripting class. And basically all you do is you select that top node, in this case for this butterfly, which is pointing down the x-axis as we would want. You launch the instance copy script. You enter a name. So in this case, I'll call it, butterflies. It asks you how many frames you want to do. So frame 1 to frame 20, because that's how many frames I have animation on this butterfly. And then it asks you by frame. Well, we want to copy every frame. So instead of 1 to 20, our start frame is 1, our end frame is 20, and our by frame is 1. And then it asks if we want to group the instance copies. That's up to you. Doesn't matter. And then once we do that, with the butterfly selected, we just hit Make Copies. It runs through, and now what you can see is it created our library for us of the butterflies with the wings up, wings down, and wing back up. So it's a very, very handy script when you're working with the instancer. It saves you a lot of tedious work. And then the other thing is what we now would need to do is before we go to the instancer, you'd need to select them in the right order. And you can see if you look in the outliner, we have butterflies 1, 2, 3, 4, 5. If you have 150 of them, selecting them in the right order could be also tedious. And so again, you can use David's script, where I can just go in and write butterflies, enter a start frame of 1, end frame of 20. But then, instead of hitting the Make Copies button, I'll hit the Select Copies button. And now you can see that it has selected them, and it does select them in the right order for you. So if we now open a scene where we're going to be working with this, I'm going to go into this one. I already have an instancer node in here, but I'm going to get rid of it. So let me delete the instancer node. Let's get our butterflies back. So display, show selection. We can see that we've got, and in here what I'm going to want to do is turn this left panel into the outliner. And then let's switch to a different camera, so that we can see that we've got our butterfly library. So what we're going to want to do then is we also can see that I have a particle object that's in the scene, and the particle object is already moving with a couple fields. So if I go back to frame 1 and I hit play, I can see those particles are just sort of moving with a uniform field and with a turbulence field. So I will go in here, select these butterflies in the right order by using the instance copier script. So butterfly underscore from 1 to 20, select copies. And now with them selected, I will go to the instancer. And then in the instancer, you will see that all of those butterflies will be listed. Now, when we created that asteroid belt, we used multiple objects, but Maya did not cycle through them. It didn't animate through the list. We used the object index attribute to control which object in the list was being used. Well, now what we're going to do is if we look at the top, you'll see that it says cycle, which has been set to none for everything we've been doing so far. Well, now I'm going to switch that from none to sequential. And that means that each particle will cycle through the list. The way that it cycles through the list is determined by your cycle step units, and you can either choose frames or seconds. The default is frames, which is fine. Then the cycle step size is 1. And so that basically means that every frame, each particle will move on to the next object in the list. And so now if I hit create, and also my aim direction, I will set to velocity. So I'll hit create, and now for my particles, I'm going to get those to be points again. And we can see that we now, if I hide my library of butterflies, so display hide selection, I now have, let's select the instancer, a bunch of butterflies, and they are animated. But the thing is that they are all animated at the exact same speed. And they all have their wings up at the same time and down at the same time. Well, the first thing you can change is instead of changing the speed, you might want them all to be flapping their wings at the same speed, but not necessarily all start with their wings up. Well, if we select the particle object and go to the instancer folder, there are a couple attributes that we're going to use. If you look at the bottom of the instancer folder, it says cycle options, and you have cycle start object and you have age. Cycle start object is what will determine which object in your list is used at the birth of the particle. By default, they all use the first object in the list. Well, as we've done before, we will create a custom attribute, which I will call custom_start. That will be a float per particle array. We know that we have 20 butterflies in our list, and so what I will do is delete the expressions that are already on this particle object, and then write an expression so that particle shape1.customStart equals rand20, and hit create. So if I use this as my creation expression, and then I go to cycle start object in the instancer folder, and I will map custom_start to the cycle start object. And when we go back to frame 1, there you go. So you can see some butterflies have the wings down, and some butterflies have the wings up. So they are all flapping their wings at the exact same speed, at the same rate. The thing is that it now is going to look a lot more natural because of the fact that they are not all starting at the exact same point. So sometimes you can just get away with this, because in the case that you're doing something, whether it's fish or birds or whatever, if they are all flying at the same speed, it might be normal for them to be flapping their wings at the same rate. And this is a very straightforward method, let's say for something like these butterflies. But now we want to move on to a situation where we do actually care about the speed controlling the rate at which we move through the list. And so for this example, we'll move on to, let's say, those little robots that were walking around. I'm going to go in and open a scene where what we will see in here is that I've got these robots just walking around in a circle, and then they start walking towards the camera. Well, what I have in here is I have a vortex field and a uniform field. The vortex field is at frame 1. It then fades off, the uniform field fades on, and the particles have their conserve set to 0. And right now, all of these particles are walking exactly the same way. Well, what I'm going to want to do is I'm going to go in and delete this particle object that they're on, and delete the instancer node. And then I'm going to get another particle object to be visible that's already in the scene. And if I hit play, it's this one. Using goals again, I have some particles that are flowing along this surface. And so I'm going to get some particles or some robots to walk down the street. So right now, all of these particles are flowing down that surface at exactly the same speed. And they're moving a little fast. So I'm going to go and change their lifespan, let's say to 5 seconds. So it now takes those particles 5 seconds to move across that ground plane. And so what we next need to do is create the instancer. So we need to select our robots in the right order. For the robot, I animated it with over 30 frames, or a 30-frame walk cycle. And so I'm going to go to the instance copier script, type in bot _, start frame is 1, end frame is 30, select copies. Now I've got my robots selected in the correct order. And also, if I make them visible, we can see there is my little army of robots, all at a different state of walking. So we can see that they're all in there. Let's select them again. So instance copier, bot _ from 1 to 30, select copies. With them selected, I will go to the instancer. Cycle will be set to sequential. I can see that they're all selected in the correct order. If they weren't, I could select one and use the move up button or the move down button to change the order. Particle object to instance is particle shape 2. And then I'm going to choose aim direction equals velocity again. And then down at the bottom, custom start object is set to none, and age is set to age. And age is what we're about to start talking about. I'll hit create, and when we hit play, first let's hide our robot library. So let's hide that. And now when we hit play, we're going to see this, where we've got a whole bunch of robots. And let's select the instancer node, or let's just go into flat shaded mode and turn on wireframe unshaded. Now we can see we've got all these robots that are walking down the ground plane. But the thing to point out about them as they walk down is, first of all, we have quite a few of them, which is fine. It depends on what you're trying to do. If you're trying to create an army versus just a few. But let's actually lower the rate down on our emitter so that we don't have quite so many robots, just so our performance is a little better. And now what you can notice is those particles are sliding. Their feet are sliding on the ground. Well, that's because the particle is moving faster than the feet are moving. And so what we actually need to do is augment the speed at which each particle moves through the list. And that's something that can be done by selecting the particle object and changing how the age is controlled. If you go to the instancer folder, you have an attribute called age. And by default, that is mapped to age, or the age of the particle. So that every frame that the particle gets older, it moves on to the next object in the object list. Well, if you write an expression on the age of the instancer so that age equals age times 2, the particle will move twice as fast through the object list. So what we're going to do is create another custom attribute, which is going to be called custom age. So go in here and say attribute name custom underscore age. It's a float per particle array, and I'll hit add. Then I will write a runtime expression, because age changes every frame, so it needs to be runtime. And the runtime expression that I'm going to write on here, if we first start by just saying, and let me get rid of all this, particle2shape.customeAge equals, and then we'll go in here and say particle2shape.age, they're going to move at the exact same rate. So I'm saying custom age equals age. So if I go back out to Maya and enter that as my expression and hit create, I will then go to the instancer folder and map age to custom age. When I hit play, we're going to see that they're walking at the exact same speed. But now if I edit the runtime expression that I have on custom age and say custom age equals particle shape age times 4 and hit edit, now notice that they are walking twice as fast. So what you would need to do is I could either go in here and figure out the right multiplier manually, so maybe age times 2 and hit play. And now it's looking a little bit better and the feet aren't sliding quite as much. But the thing is, what you really want to do is have the speed of the particle determine how fast they move through the cycle. The way that you can query the speed that a particle is moving is by going in and creating a new variable. I'm going to write a variable called speed. So float $speed equals, and then I'm going to use the magnitude function. So equals mag, and then particle2shape.velocity. And what this means is float speed is going to be a float, not a vector, but the velocity of a particle is a vector. So if the velocity equals 0, 10, 0, it would mean that the particle was moving in the y direction at a rate or a speed of 10 units per second. When you take the mag, or the magnitude of velocity, it gives you speed, basically. So I have a new variable now called speed. So what I'm going to do in here then is say particle2shape.customeAge equals particle2shape.age times speed. So now the speed of the particle becomes your multiplier to determine how fast the particle should move through the list. That's not necessarily going to be the correct number in the sense that speed might be too fast. You might have to say times speed divided by 10. But first let's go in here, copy this, paste this into the expression editor as our new runtime expression, and then now what you're going to want to do is hit play and see that they're walking way too fast. So what I will now do is try and edit my expression so it's speed divided by 10 and hit edit. You have to basically keep playing with that divider until the feet are no longer sliding through the floor. And so now there looks like they're maybe moving too slow. So maybe speed divided by 5, edit. And now that looks a little bit better. And so at this point the feet don't really look like they're sliding quite so much as the particles move along the surface. Now they're still moving a little quick, so I could grab the particle object and edit its age or lifespan. So if I edit the lifespan so they live 8 seconds, or let's say 10 seconds, now it's going to take the particles 10 seconds to get from one side of that surface to the other. And then if I go in here and hit play, now they're moving a little slower, and you can see that it doesn't really look like those feet are sliding through the surface quite so much. But the thing is that since they're all moving the same speed, it's hard to tell if the speed is actually determining it. So the way I can now get the particles to have some of the robots move fast and some move slow is I will select the particle object and edit its lifespan so that it equals a random range. And because that's the lifespan of the particles determine how long it takes them to get from one side of the surface to the other. So that if now the particles are moving at a different speed, let's go and hit play. Now what we're going to see is this. Notice that the robot that is, the particle that's moving faster has a robot that's moving faster. And there you go. And so now we've got robots where the speed that they're walking down the street, as far as the speed at which they're moving through the sequence, is based on how fast the actual particle is moving. So it's a very useful technique that you may want to use to get more natural results using the instancer when you're trying to do animated characters, whether it is robots or spiders or whatever. And that's basically that. So if I look at something like like these flying saucers, basically instead of having walking characters, I have spinning saucers. But in that scene, I just have the rotation that they spin be based on how fast they're moving. And so I animated a flying saucer that's just spinning around. I used the instance copy script to make my copies. So I have 80 flying saucers in the scene, each one rotated a different amount. So you can see I have a whole bunch of saucers in here. And all of the copies were made for me by the script. And then when I go in here, if I hit play, as these particles are created, they're created with a low velocity, and then a uniform field that has attenuation starts speeding up those flying saucers. And then the faster they go, the faster they will start to spin, because the age of the instancer is based on a custom age attribute that is related to speed. And so in here, we'll be able to see that these flying saucers are spinning around. It's a little hard to tell because of the playback right now that they start to spin faster as they speed up, but they do. And if I select the particle object and go to the outliner, or rather the attribute editor, we'll be able to see, if we look at the expressions, is I have an expression on custom age, where if we look at it, it says right here, particle shape 1.custom age equals particle shape 1.age times $speed divided by 10. And therefore, they start to spin faster as they move faster. So that's the basics of the instancer. We've talked about everything you need to know to get, whether it's static geometry, a library of geometry, or how to get animated surfaces onto the particles, where either they are, controlled via expressions based on age, having them have a different start point like we did with the butterflies. And the final thing to point out is the fact that when you do it the way we did it, let's say with the butterflies initially, just taking an animated object and putting it on the particles, you'll be able to use motion blur correctly. But when you do it this way, where you cycle through the object list, motion blur will not work correctly. When you do an asteroid belt, where you use select from your library of objects for your particles, motion blur will work okay. But when you do something like what we just did with the robots, motion blur is not going to work correctly, because technically you do not have animated geometry. Maya is just substituting the visibility of geometry as it cycles through that list. So that's just an important point to make. So if motion blur is very important for what you're doing, you'd have to use the first technique, where you actually create or put animated objects onto the particles, doing it that way. So that's the basics of the instancer, and there you go. So the last thing that we're going to talk about is a script which can be useful to get something kind of like the instancer, but it's actually not going to use the instancer, which is something which you can get at high end. It's called the GAMS particle replacer script, and it allows you to replace particles with any object in Maya, or any node that can be duplicated. So as opposed to the instancer, which makes instance copies, which has limitations of you, for example, not being able to get lights onto particles, what this script will do is it'll take any particle object and a selected piece of geometry, and then create a motion path from each particle, and then assign that piece of geometry onto those motion paths for you. And so what I'm looking at right now is a scene which has particles, but what we will also notice is that there are these curves in the scene, and these curves were created by the script. So that and then we also have lights which have optical effect nodes on them. And so if we take a look in here, we can see that there are glow effects, which are optical effects on our lights, and we can see how these are actually illuminating the scene, while those particles that created the motion paths are also emitters that are creating those little trails behind them. And so as far as using the script, it's very straightforward. What you want to go in and do is you need to download the script either from High-End or from the Gnomon Workshop website, source the script, and then you just type in JMS_PR. And so if we have a scene like this where we have an emitter which is emitting some particles which we want to illuminate the scene, what you would do is you would first go in and select the particle object. So I'm going to select the particles. Then I'm going to shift select a point light which is in the scene. And then I'm going to type in JMS_PR. In the window that pops up, you can specify a start and end time, but the end time only goes up to 100. So there's a checkbox underneath that says use time slider, and I'm going to check that. My time slider goes from frame 1 to 140. Then it has checkboxes for random scale, random twist, or align geometry, which are pretty self-explanatory. So for a point light, we don't care about aligning anything. And then it has a delete particles checkbox, which is up to you. And then there's a button that just says do it. And so if I hit go, what it's going to do is it's going to run through the animation once for each emitter that's in the scene. And then what it's going to do is create motion paths for you from that. And so if I now go in and select these curves, you will see that there are actually curves in the scene. And if I go and back to frame 1 and I hit play, we'll be able to see that we now have lights replacing those particles. Something that's important to point out, though, is the fact that since it uses motion paths, make sure before you execute the script that your animation tangent curves are set to spline or linear, because otherwise you're going to not have your light keeping up with your particles. So it's a very, very handy script that can be used for these kind of effects. And just in general, when you need to replace geometry or particles with geometry using motion paths, as opposed to just relying on the dynamics. Another example of something like that is this one, where I created these flaming arrows that then land and get stuck in the ground. So if I just use the instancer, I wouldn't be able to really get them to stick in the ground, because once the particle stops on the ground, the velocity would change and the arrow would no longer be oriented correctly. So by converting the particle animation to motion paths, I was able to get the arrows to stop and maintain the correct orientation when they get stuck in the ground. So again, that's just that script I wanted to show you, just so you understand how lights can be done. And there you go.